Hello, welcome back to Cracking the Cryptic. Now, not long ago, I did a puzzle by more Sudoku 90 called Chi that was very interesting, very worthy. And this grid is absolutely covered with spaghetti and meatballs, and I'm looking forward to finding out what we have to do with it. So do wait for the rules on this one. I'm going to very briefly tell you about, well, streaming Monday nights normally, although last a couple of days ago it was Sunday and we were in Lorelei and the Laser Eyes. There were some very interesting puzzles there. Well worth watching the VOD of that. Of course, we do Minute Cryptic every day and Wordle in a Minute, 2 Sudoku videos, and there's Friday Cryptic Masterclasses. And on Patreon, you can see other cryptic crosswords and gridogram and connections videos. So many puzzles that we're trying to get through. And of course, also the monthly Sudoku hunts are on Patreon as well. This month, it's No Trump Game. Do check it out. It's entertaining, quite challenging puzzles based on playing cards. And we've also got our apps. They feature Line Sudoku, Classic Sudoku 2, and the Worms. And we've got merch by Marty Sears in many cases, the Rat Run merch. Get yourself a mug to drink from with Rat Run on it. And there's some Cracking the Cryptic merch as well. Look on the links in the description field under the video. There will be a link to this puzzle. It will be the first one. It's called Spaghetti and Meatballs. Let's see what the rules are. Normal Sudoku rules apply. 1 to 9 in every row, column, and 3 by 3 box. All combined circled digits have the same sum as all the combined digits on lines. Wow, okay. On the lines, so digits connected by, these are not Dutch Whisper orange lines. Digits connected by an orange line in this puzzle have a difference of at least 2. That's not much of a difference. So it's like a sort of Nabna line. No, it's not. It's not at all. Just read the rule. Digits connected by an orange line. So any 2 digits connected by an orange line have a difference of at least 2. Digits can't repeat on a line. A digit in a circle, n, appears n number of times in circles. So for example, a 5 in one circle means there will be a total of 5 circled 5s. And a digit in a circle cannot be a knight's move away from an identical digit. Okay, that is an odd selective knight's move rule and might matter, and Nighty McKnight faces here to help me. Give it a try. This is probably very hard. Let's get cracking. Let's see what we can possibly do. We can count the circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 21, 24, 25, 26, 27. So the digits that do go in circles, the discrete different digits that go in circles will add up to 27. Because if there were 9 of one type, that would take up 9 cells of 9, etc. Oh, there is this very odd issue of all the combined circled digits add up. Ah, right. Look at this cell. This is a very important cell in the puzzle because it makes the puzzle work. Because we know a secret about every row, column, and box in a Sudoku, and that's that it adds up to 45. That allows us to derive a secret about the whole sum of a Sudoku grid. 45 times 9 is 405. So if every digit was on a circle or a line, the whole thing wouldn't work because 405 is an odd number, and we're told that the x given by the total number of circle digits is the same as the y given by the total number of line digits. Anyway, sorry, I'm getting distracted in my mind by the next question that I have to answer after telling you that x plus x, which is the sum of either the circle digits or the line digits, must come to a number that is 405 minus this cell. This cell must be odd to allow that number, the half of it, to be an integer. If this was a 1, the number would be 404 divided by 2, 202 in all the circles, 202 in all the lines. If this number was a 9, 405 minus 9 is 396, divided by 2 is 198. So the total in the circles and the lines is somewhere between 198 and 202. And the next question that I'm getting stressed about in my head is if we have 27 circles and the digits in them add up to within 2 of 200, we could... The digits that add up to 27 out of the 45 of Sudoku digits, if you square those digits, you get to within 2 of 200. Is there any chance that that lets us work out what they are? And the answer is definitely no. Well, what is the maximum it could be if we had 9, 8, and 7 in the circles, and a 3? That would add up to 27. That would definitely give us the maximum of squares, right? What would the squares of those numbers be? 81, 64, 49, and 9. Actually, this is somewhere near 200. 81 and 49 is 130. 194, 203. Oh my goodness. Well, that's very close, but it's a fraction too high. If you had 9873 as the circle digits, you would have these totals in the circles, and the whole grid would add up to 203 times 2 is 406 plus this orange cell. And it would be broken. But we're very close. So let's say it's 986 and... no. Well, this is not going to be enough, I think. 986 and 4 would give us 16. 80, that's 100, 181, 197. That is not enough. This is really strange. Right, this is with, this is all my aide-memoire space. That's with 9864 as the digits going in circles. And I started with 9873, and that was just too much. Now, I do know how to reduce that by a fraction. And that is because I've been assuming there were 4 digits involved, but there might be 5. So 98721 would give me 90 and 40, 130, 194, 198, 199. That is right in this sweet spot of 198 to 202. Oh yeah. Yesterday was the sweet spot puzzle. Now, what I have to now try and prove is that I need these huge numbers to go into my square calculation. If I did 986, and then I've still got, that's 23, I've still got 4 more. I could do 3 and 1 instead of 4, but that would give me 10 to add on instead of 16. Like, dividing up any sort of bigger number is pointless. You get much smaller numbers. If I tried to divide up 6 into 4 and 2, I wouldn't have 36. I'd have 16 plus 4. It's 20. It's miles short. I don't think, and at the moment, 181, 190, 191, I'm now not getting close to 198. The only way I can possibly do it is by going 987. If I go 9874, I'm too high. 9873, I'm too high. So I go 98721. I think this is the only way to do it, which is an extraordinary calculation that there is only one way to achieve this. But I think we've just done it. Hats off to us. I mean, if you don't have 9 squared is 81, you're just never going to approach the numbers needed with the other. Like if you replaced 9 with 6 and 3, you'd get 36 plus 9 out of that is 45. You'd be miles short of 81. You can't replace 9. You can't replace 8. We've proved you can't replace 7 because you just won't get there. So it's got to be this. Right. The digits in circles are 9, 8, 7, 2, and 1. And we've got to find places for 9 and 8 in every, for 9 in every single box and row and column. Every 9 in the puzzle is circled. So one of those two cells in box 6 is a 9. I'm literally just going to put my aid memoir here of circled digits. Actually, I know what this is as well, don't I? So when I did my maths, 98721 was 81 plus 64 plus 49 plus 4 plus 1. What was that? It was not that. It was 98621, wasn't it? This is it. So, no, 98721. It was this calculation. 142, no, 130, 194, 198, 199. So we double 199, we get 398, and we need 7 more left over in that cell. Well, that's quite interesting because we've got to get 7 sevens into circles as well as 9 nines and 8 eights. I think it's going to be very difficult to do. It's going to be quite constraining. Anyway, 9 is in one of those two cells, so that's not a 9. So the 9 in a circle in box 9 is in one of those two. The 9 in a circle in box 3 is in one of those. One of these two is a 9. Oh, the 9 in this row is in a circle. That's that one. Found one of them. Hurrah. Oh, how do we do the rest? I don't know. But we've also got the problem of putting 8 eights. Right. The 8 in this row is not in a circle because there's no other circles in the row after the 9. So every other 8 in the puzzle is in a circle, and that's going to include the 8s in boxes 1, 2, 3, 7, 8, and 9. Now, how am I going to use that? Doesn't prove this is an 8, but there have to be 2 8s in circles in these rows, don't there? Simon is so much better at this aspect of circle puzzles than I am. And we also have to get 7 sevens into circles. This 7 is not in a circle, and the 7 in this row is not in a circle, so all the other 7s are. So this row has a 7 and an 8 in circles. This row has an 8 in a circle. And all the other boxes have 9, 8, and 7 in circles, including this box, this box, this box, and this box, all of which have only 3 circles. This can have 2 in circles there, and this must be a 7, 8, or 9. This one can only have one inner circle there, so both of these are in. Okay, that 7 is looking at these two cells and making this the 7 in box 2. These now can't be 7s. That one can't be a 9 from what we worked out earlier, nor can that. This circle is not 9, 8, or 7. So the 7, 8, and 9 in circles in this row are no, yes. Yes. One of these is a 9 and one of them is an 8 in that row. And in this row, there is a 9, 8, and a 7 all in circles, and they're not in that circle, so they're in these ones. It's so hard for me to just work out what is really basic. One of these is a 7 in this box now, and now that can't be a 7 and is an 8. That makes this a 7. These two are now a 9, 8 pair looking up at a 7 there. Now I've got an 8, 9 pair in this row, and one of those two is a 7, so this isn't a 7. That's an 8, 9 pair looking at a 7 here. 7 and 8 in this row are looking at a 9 there. That fixes 8 and 9 in the middle row. That is not able to be a 9. 8, 9, 7. This one is the non-7, 8, or 9 in this box. So 7 goes there. And then there's an 8, 9 pair on this side. 7 can't be in those cells, so it's here. Just going to remove the corner marks. Now I've got these sort of, I can't really resolve those 8, 9 dichotomies. Oh, it's going to be the knight's move that does that. Oh, this is super. This is so clever. And look, these are all 8, 9. Oh, that can't be 7. Here's the 7. Now, I am going to use the knight's move because a digit in a circle can't be a knight's move away from another similar digit in a circle. That 8 sees this cell, so that gives us the 9 8s up here. And this 9 sees this cell, so that's an 8. And that gives us the 9 8s down here. Isn't that weird? Now, the remaining circles are 2 2s and a 1. I don't know which of those is fixing to be a 1, which one is a 2. Or which 2 are 2s. But I'm kind of done with my 9, 8, 7s and 1s. Or am I? There is one 7 left to put in the grid here. There's one 8 left to put in the grid. Somewhere it's there. And there we go. We are done with 9, 8s and 7s. And we've just barely begun on other digits with 1s and 2s. We're also done with the knight's move because there's no... Oh, maybe not. Maybe these 1s and 2s will be involved with that. We're part done with the knight's moves. Right. Now we move on to the other puzzle, which is to put 1s to 6s on these orange lines. I'll get rid of the orange out of that cell. And try and make them not have consecutive digits on a line. Is that the only constraint we have to work against? No repeats on a line. That was another interesting constraint, actually. So where does this digit go in column 9? It goes here, because it can't repeat on its line. And then it goes here, because it's not 9, 8, or 7. Yeah, I mean, that's interesting. These 2 digits have to be these 2 digits so they don't repeat on their line. Oh, okay, that's getting a bit weird. Let's go with yellow there. These 2 have to be these 2 so they don't repeat on their line. This, no, that's, well, it's one of these 3. Where are these? Wow, I really don't understand the questions well, do I? Let's color these 2 as well, blue, because they can't repeat on this line. but they could be in any of these cells. That green is going to be the same as that green and must sit here in box 7. So let's give it a different color, maybe a different, well, we'll call it grey for now. That green is in one of these two. This digit is not green or grey, and it's not allowed to be blue, so it's one of the yellows. The other yellow in this box is here by Sudoku, and those two yellows are up here. That's weird, isn't it? Oh, this is a very different phase of the puzzle now. This is a very interesting phase of the puzzle, though. This is about not repeating on lines. It's not about what the numbers are. It's about no repeats. I do find this very confusing. I cannot deny that. This digit is not allowed on this line, so it's in one of those two cells. Oh, we know that green is a 1 or a 2. I mean, it might be the same as this, but we don't know that. There's also a yellow 1 or a 2. So those two are different from each other. I mean, that's bonkers, but we do know that one of those is a 1 and one of those is a 2. So this is a second 2 in a circle. Whatever this is down here is a 2. I don't know whether it's the green circle or the yellow circle 2. Right, this digit is not the 1 or 2 because it would be connected with a difference of 1. Oh, that's mad. So this is the yellow, the circled 1 or 2. Oh, that digit is the same as that one because it can't be the same as that one. So the 1 or 2 is known over here. It's in that position. And then one of these two is that yellow 1 or 2. But oh, that yellow can't appear again on this line. I was going to say, where's that yellow in this column? And that it has to be here. But of course, it could be pink. And it might not be flouting any Knight's Move rule because it's not in a circle. Yeah, these pinks, I don't know what color they are based. I've got much more interesting color scheme going on. Oh, by the way, I needed double blue in box 1, so they're here. And these 2 blues, well, I need 2 blues here, but 2 is either green or yellow, isn't it? So it must be green. And those are the 2 blues. And now we know that green 2 in a sorry, this must be 2, mustn't it? Because it's green, and that's the digit in a circle. So this one is a 1. Wow. I mean, that's madness. Right, these 2 digits cannot be 3s because they'd be touching that 2. It's such tiny information, it's not worth it. Now, can this pink still be yellow? It can't be the other yellow that's not 1 because they're in the same row. And it can't be this yellow that is 1 because it would be a Knight's Move away from there. So this pink thing is not yellow, and that yellow does not appear here. And in this column, it must appear there. That is the yellow that is not 1. Maybe I should come up with a different... Let's have light blue. No, let's have orange. Yellow and orange are the pair of yellows. And we'll have light blue and dark blue be the pair of blues. Now, how do I go about the rest? Oh, grey in this box can't be on this line, so it's definitely there. And that makes this one grey unless purple is grey, which is, unless pink is grey. That is definitely possible. I don't know what pink is, but I know it's not yellow. It can't be this shade of dark or light blue, but it could certainly be grey or green. I'm going to give it a letter instead of a colour because I don't know what it is, and it's important to distinguish it from the colours which are actually working here a bit. Now, yellow and orange there, so this can't be green or grey, so it's a shade of blue. And in fact, in this row, that's also a shade of blue. I don't know which type of blue it is, but grey has to be in one of these three places. Grey is in one of those two. Orange isn't allowed to be there by Knight's Move or here, so orange is in one of those two. It's not quite as helpful as it. Oh, grey in this column can't be on that line, so it must be here. So it is A. Aha. That's the sort of thing we wanted. I can get rid of that A. A is grey. That's A in the greyness. Now, one of these two is grey. One of these two is grey. Let's mark those. That's the last X-wing on greys. Okay. One of these two is yellow, but it's not that one because it would be on the same line. So that's yellow. Now one of those two is yellow. I don't have a Knight's Move restriction. I also know one of these three is yellow. Do I know where yellow is up here? Yellow's in one of those two. And where did I say down here? One of these three. That's not very good, is it? And one of those two, I am going to mark that. Okay, what about orange? We know orange is in one of these two. I'm going to have to use the blooming numbers in a moment, but I've got no numbers on these lines at all. One is orange. Two is green. I haven't placed a lot of green, have I? Green's in one of these three cells, one of these three cells, one of those three, one of these three. Okay, so green in this column. In fact, these are green and double blue. That one's not allowed to be green, so that must be double blue. I mean, blue or blue is what I mean. Please don't tell me this is a lot easier than I'm finding it, because I don't understand how to do it if it is. I think this is pretty difficult. I was going to say that's not green because 2 can't be next to 1, but it wouldn't actually be next to 1. Okay, I can say this isn't orange because it would be a 1 and it would be touching 2 on a line wherever the 2 appears. So if that's not orange, and these aren't. Orange is in one of these two along with grey. That's weird, but pretty useful. Or pretty interesting, at least. If that's orange and grey, and these are double blue and green, that's yellow. That's how it's useful. That one is not yellow, and this one definitely is now. Also, that is now definitely not yellow, therefore it's orange. And this one definitely is yellow, and that one definitely isn't, and this one definitely is. And all the yellows are placed. Orange and grey are down here, and orange is a 1, so grey is not a 2. Well, we kind of knew that. One of these is a 2. Now, that is also going to tell me that yellow is not a 3. Because it would be touching a 2. So yellow is 4, 5, or 6. I am not scared to pencil mark that in. And yellow's done. Right, orange, or grey is nearly done, but not quite. Now, there are other colours to do. Oh, this bottom row, the last one is one shade of blue. How am I ever going to... I haven't even chosen any of the shades of blue anywhere, have I? Interesting. Let's bear that in mind as well. Now, remaining colours in this final column are green, orange, and another blue of some sort. This digit is not grey or yellow. And in this box, it can't be in those cells, so it must be there. Whatever this is there and here. Let's just try and pursue this digit around the grid a little. Trouble is, all I know is it's not yellow or grey. It could be orange in those positions. It could be green. Oh, we do know from a 7 on this line, which is the only instance of 7, 8, or 9 appearing on a line, that this digit, this grey, is not 6. It's also not 1 or 2. So grey is 3, 4, or 5. And it appears down here with a 1. I mean, that's quite interesting. Oh, look, grey is next to 2 here, so it's not 3. Grey is 4 or 5. And what else is grey next to? Because there must be somewhere. It's only orange that it's touching so far. What I do know is that grey can never touch 4 or 5. So this digit, didn't we say these 3 are the same? Whatever they are, they're not 4 or 5 because they'd be touching grey. They're also not 6 because in this position, it would be touching 5 and 4. So these ones are 1, 2, or 3. And they're the same. I'm going to have to give them a letter again. Well, let's go B this time. That's quite interesting. I can't quite say from this that it's not 3, because that could be 5 and 6. That's such a weird puzzle. I love it, actually. I do love it. I'd love to know what B is. I feel like I probably should know at this point what B is. But I definitely don't. B, I was going to say it's not orange or grey, but it could be orange. It's not yellow or grey. And it's not this. I don't know what that is. This digit can't be 2. Well, we knew that. That's no good. In this row, one of the blues is a 3. That's quite interesting. I hadn't known that before. One of the blues is a 3. So I could pencil mark 3s into a lot of these places as an interesting finding. And that means the other blue cannot be 4. So the other blue, according to column 3, must be 5 or 6. I mean, that's quite interesting. Surely. Now, where are they going to be meeting up with stuff? So the blues are 3 and 5 or 6. The grey is 4 or 5. And the yellow is 4, 5 or 6. Here is, if this was 3, that B would have to be 1, orange. If this was 5 or 6, this yellow would have to be 4. Those are both very powerful conclusions and would do a lot, but I don't know which is true. These digits are from 3, 5 or 6. For that to be a 3, this couldn't be 2. 2 would be down here. Goodness me, we're very close to finding out what's going on now. A step away, would you say? A knight's move away somehow? I don't feel like the knight's move has anything left. You know, it might apply to this one. I don't think it does, because none of the cells a knight's move away from that can be a 1. So I don't think the knight's move has anything left to teach me in this puzzle, which is a crying shame, because I was hoping that might be what I was missing. These are from 3, 5 or 6. Now, if B was a 3, yellow would have to be 6, grey would be 5, and this couldn't be filled in this box. So B is not 3. B is either orange 1 or green 2. Is one of them impossible? Oh, that's a 1. I haven't written that in. Look at that, an actual digit I can just write in, and I hadn't bothered. This. I mean, this is so interesting. If yellow is a 4, this digit has to be a 6. If yellow is 5 or 6, that digit has to be 3. I don't think this digit, as it goes, can ever be 5 sitting next to that, and that's clearly true. In fact, that's quite interesting. Even 4, 5, 6, you can never have 5 sitting next to it. Well, it's quite interesting. It's not very interesting. Oh, no, it is interesting here. Right, first of all, where does 5 go in this box? It doesn't go here or here, because it would be sitting next to a 4 or a 6. It doesn't go here or here, because it would be sitting next to a 4. So 5 is one of yellow or grey, definitely. And that means 5 is not one of the blue digits. So the blue digits are 3 and 6. That is a really good conclusion. The blue digits are 3 and 6. I think that's a really good conclusion, and yet I don't quite know why yet. I thought it was going to teach me something somewhere, but I don't know where it was. Yeah, the blue digits are 3 and 6, so yellow is not 6. So yellow and grey are 4 and 5. That's a good conclusion. Because they can never be next to each other now, under any circumstance, or not along a line, under any circumstances. But have we finished all yellows and greys? Not quite. Yeah, this can't be grey for that reason, exactly. So this is grey, and this is grey, and this one is orange and is 1. And that's going to give me orange 1 up here. One of those two, one of those two. Come on, there must be something. One of those two are 1s. Okay, that's not a 1. That's 4 or 5. Have we done all greys and yellows now? I think we have. There's 2 of those in each box. Yeah, we've done all grey and yellow. We haven't differentiated between the blues, but they're always 3 and 6. So green is 2 and orange is 1. Right. This group includes 2, 3, and 6. Those 2 are joined, so they can't be 2 and 3. They must include a 6. This one doesn't. This one can't be a 3 because it's joined to both 4 and 5 on the line. That digit is a 2, and 2 is green. And now this is 3, 6 double blue. We've had 3, 6 in this row. We've got 1, 2 left over here and here. And this is 3 or 6. I know I really am going to have to get to the point where I select which blue is which blue. But I have not got there yet. I'm not forcing myself. These are a 2, 3, 6 triple, and those 2 must include a 6. Because they can't be 2, 3 touching each other. So that's not a 6. This one is 2 or 3. It's close to yielding something as well. What is the coloured one? 2 is green, isn't it? These are also 2, 3, 6. It's the same deal again. 6 has to be on that bit, so 2 and 3 aren't touching. So that's not 6. Oh, 8 is on this line, but it doesn't help. That digit is 2 or 3, and I don't know which is which. This one is obviously blue and not 2 by just ordinary Sudoku. This is also blue. Some shade of blue. Right, this digit is not blue because whether it was 3 or 6, it would be touching both 4 and 5. So this is the other blue. This is 1 or 2, and that is green. And this is the one we called B, which was going to be in these positions, and it's now 1 and is orange. That is 2 and is blue. One of these 2 is a 2. And again, we've got a 2, 3, 6 triple. If we know that 2's in one of those, we know 3 isn't. And in fact, 2 and 3 have to be kept apart on this line. So it's got to be 3, 6, 2. And that's 3 in the corner. That's 3 in the spotlight. Right. This one is a blue. This is green. That is now not green. This one is green and is 2, and that's probably all the 2's done. I can write the last one in there. Now I have to choose colours for blues. So we'll have it dark blue in the corner where the 3 was, and let's see if we can propagate that around. I bet we can now. I bet we can. So this is sitting next to a 2, so it has to be 6, which is light blue. That's how to do it. When you finally get a handle on this, it is very doable. Now, we need to find something touching a 2 up here, or we need to identify... that's not happening. So we need to identify the 4's and the 5's somewhere down here from what 6 or 3 is touching. Right, these blues, dark blues, are 3's. One of them is touching there. Yellow has to be 5. so that it's not touching 4. Grey is 4. Look at that. These dark light blues are 6s. All the bottom 6 rows are completely done. 4 is not allowed to touch 3 there. So these 3 cells are light blue. These 3 are dark blue and are 3s. And these 2 are 6s. And that might finish the puzzle. What an extraordinary thing. That is a lovely idea. Spaghetti and Meatballs by More Sudoku 90. And a very clever idea that is too. And it's made me hungry for lunch. Right, thank you so much for watching. What an intriguing idea. A puzzle very much in separate stages, but a really interesting piece of work. Some tough maths, I thought, at the beginning. Then some weird colouring. I probably missed a stage. Yeah, then the circle identification was a fun stage. Then the weird colouring. And then the digit disambiguation. Wow! An absolute journey. Thank you for watching us on the channel. Such a pleasure to be with you. And please come back for more soon. Bye for now.